So, outlier ID method number 1. And for this, you have to have bell-shaped data. This won't work without it. Why do you think you have to have bell-shaped data? I.e., what do you think we're going to be using?
Standard deviation.
Standard deviation.
Yes, and the average. You have to have a standard deviation and an average that are worth using. And the only time, by vote, they're worth using is if you have bell-shaped data. Because that means that they're not being skewed with extremely skewed data. Yes, good, good. So, if, and it's a big if you have bell-shaped data, and this is a pretty universal rule. This is used in all research statistics and things like that. Outliers are data points outside of 2 standard deviations. Why 2 standard deviations? Very, very close. Within 2 standard deviations, what's that percentage we get within 2? 95. So if you're outside of those 2 standard deviations, what have you identified? The most extreme, what percent? 5%. You've identified the most extreme 5%. Why 2 standard deviations? Why not 3? Why not 4? Why not 1? There's no good answer for that. It's what's used. I'm not saying it should always be used. I'm not saying it should always be used. I'm saying it is what is used. It's kind of like why we drive on the right side of the road. Because we do. I'm not saying it's the best thing to do. We just do. 5% or 95, depending on how you want to look at this. The 5% rule for outliers is in research. How many of you guys have taken sociology, psychology, HDFS classes? Have you studied p-values in those classes? What are the p-values usually marked as? Less than 5%. Why? Because of this rule. We have fallen into this habit of always marking anything that happens less than 5% of the time as an outlier. I'm not saying it's always a bad thing. I'm saying sometimes we get ourselves in trouble. Because what is 5% as a fraction? 1 out of what? 1 out of 20. 1 out of 20. Which means a data set out of every 20 elements should have 1 outlier out of 20 on average. That doesn't guarantee that every data set is going to have them. It says on average a data set should have 1 out of 20. Sometimes you get 5 in a row, or sometimes you won't get any, but on average it's going to smooth out to 1 in 20. So whether or not this should be used as a marking mechanism for publication is up for argument. We'll talk about that in 244 more. But that's a very, very standard definition of outliers. By that rule, do we have any? By that rule, does our data have any? Well, I don't know. Let's figure it out. Let's figure it out based on our data. Because we know what the standard deviations are, or we know what the standard deviation is. It's 10 pounds. And the average is 165, yes? So, we know that the average is 165 plus or minus 10. 2 standard deviations would be 20 pounds, yes? That's what you have to add and subtract from that.
You get your exact min
and look at that. When you do that, if you add and subtract 20 pounds, x bar plus or minus 2s. Is it okay to write it symbolically like that? X bar plus or minus 2s, that's 2 standard deviations. X bar plus minus 2 s's. What do we end up with, Stephen?
They all fall within.
We all fall within. Oh, whoa! Let me throw a marker away too already. You guys drink a lot of coffee. Holy crap. Outlier. So in other words, in our little tiny data set, there aren't that many data points, 20, whatever, 25, whatever there were. 24, thank you. On average, you get more than 20 outliers, but that's an average. That's not a promise that every 20 are any one. So we snuck in. All of our data points were considered typical. Even though the person who thought I was the same weight I was when I was a freshman in high school, bless you. Bless you. And even those who thought I was the weight I've never attained in my life, My true average, closest to the nearest 5 pounds? 175. Almost always 175, within a couple pounds of 175. I love it. I wear clothes that are 3 sizes too big for me, which kind of hides the fact quite a bit. But yes, and people routinely underestimate weight by 10 pounds or so. It always happens. I love that. That's why I love this data set. I think the hair throws you off too. 5 pounds of one alone.
Well, see, 175 and 1 standard deviation, I fall right in there.
You do fall within 1 standard deviation up. So 34% would be the half of that one, half of that one. It's good. 1 and 3. So in other words, but your guesses were not unusual. Even the 145 and the 185, which were the extremes. And this is where we have to talk about outliers versus just mins and maxes. Every outlier is a min or a max. Well, I shouldn't say that. I want to edit that statement. Outliers almost always are mins and maxes. But not every min and max is an outlier. They're just the smallest and largest values of a data set. They might not be unusually or atypically or anomalously large and small. They're just the biggest and smallest. If somebody had guessed 130, I'm guessing that might have been an outlier. The problem is, I'm saying I'm guessing, because if somebody guessed 130, that would change the average of the standard deviation. Because it's right? That's why I have to recalculate, correct, Aaron? Good. Very, very good. Is that fair? Good. So that's one way of tagging outliers. One way of tagging outliers. But some of you said that you didn't think this was bell-shaped data. Go ahead, be brave. Who said that? They said, no, this isn't bell-shaped enough. Oh, you're not speaking up now. Some of you did. It's okay, not the point. Some of you are like, I don't think this data is bell-shaped enough. That's okay. It's totally fine. Some of you said this data is not bell-shaped enough. I want you to go back in class. Kelly, what's that?
It's kind of a wide bell.
It is, but that's okay. It's still arguably a bell shape, although it's wide. What Kelly's saying is it's kind of a wide bell. I love that comment, by the way. We're gonna start messing with that as we go through the back half of this course with something called the central limit theorem. Very, very cool, actually.